First of all, let me tell you who I am. I'm Doran Barton. I work at Bluehost as a developer, and I'm stuck on their Linux Wrangler because my background is both doing development and doing system administration. So it only makes sense that I'm the guy on the team who, kind of works with the sysadmins and kind of helps dictate policy on how the systems are being managed and run. So, and we're here to talk about System D. I'm assuming everybody kind of sort of knows what System D is. Is there anybody who doesn't? Okay. So System D is a replacement for init. So let's talk about the Linux boot process. Kind of a review for most of you, but let's talk about what happens when you turn on your computer. When you turn on your computer, the first thing that happens is BIOS comes up, checks the hardware, does the memory checks, takes inventory of all the hardware that's connected to the motherboard and so forth. And after everything checks out okay, it loads whatever's in the master boot record on the disk. It's usually grub, used to be Lilo. And grub gives you the chance, if you want, you can choose what you want to boot to. If you do nothing, it boots to the default target. What grub does typically is it just loads the Linux kernel. And the Linux kernel loads init, which is usually in /sbin. And because init is the very first thing the kernel loads that runs, it gets a process ID of 1. And init is then it is responsible for pretty much launching everything else on the system, whether it's your Apache server or your Samba server or even your Gettys that sit there and wait for console logins, or GDM to give you a username and password prompt to log into GNOME, or KDM to log into KDE. Init is in charge of doing all that. So that's more or less a review of how the init process fits into the grand scheme of booting Linux. So System V is the AT&T Unix that was developed in the 70s. And so the init system really hasn't changed in 40 years. The System V Init that has been running on Linux machines is pretty much just a port of the System V Init. The way that System V Init works is that all the processes that need to be launched are organized into run levels. And the run level is one of these things. These are the typical run levels. If you are in run level 1, you're in a single user mode. So basically the system doesn't allow more than one person to log in. 3 is typical for a server, so it's a multi-user run level. 5 is graphical, so it's multi-user plus a graphical login. 6 is reboot, so if you go into run level 6, you're telling the system reboot, come back up into the default run level. And 0 is powered off. Does anybody know why we have a run level for powered off? Is that kind of odd?
You can type in init 0 and then it'll shut it down.
Flush the buffers and shut the disk down, ends the I/O.
Yeah, there are tasks that you want to have happen when you shut the system down. So you associate those tasks with that run level. Same thing with reboot. So these init scripts that basically launch your Apache or your Samba server or whatever else that you have associated with a specific run level are just shell scripts. And init calls those in a specific order so that if you need, for example, you want your network to be brought up before you start your Samba server. And so you want your network, the script that starts up your network, to happen before the script that launches your Samba server. And so that order makes sure that certain dependencies are met. So that's how the init system works. Now the next question is, it's been working so great for 30, 40 years. why should we replace it with something like System D? Well, first one is it's 30, 40 years old. I'm sure we can come up with something better, right? Another problem that we've only in the last 10, 20 years started to realize that we can make improvements on is the fact that in the System V Init, everything is started one after another. So with today's hardware and software, it seems to make sense that we can start things at the same time and parallelize our startup process. So that's one thing that System D does, is it gives you the parallelization that System V Init does not provide. System V Init requires bash. Now, some people would argue that's a good thing because bash scripts are pretty easy to get in and figure out what's wrong, to debug, to read. They're pretty straightforward, but it's not the fastest scripting language to be working with. Here's another thing. The fourth one I've got on there, it doesn't handle daemons that crash. So if you have, in run level 3, you say I want Apache to start up. Apache starts up and dies. Oh well. And it doesn't keep track of whether Apache stays up. It just says, I started it. From there, you're on your own. So it would be nice if we had an init system that detected, oh, something crashed, let's restart it. And some people have come up with some really convoluted ways of dealing with some modern hardware scenarios like removable storage. Init doesn't really deal with this directly. It usually spawns off other processes that say, what's your USB ports? So that if you plug in a USB drive, it does something with it. Or if you attach a Bluetooth mouse or keyboard or something, then you have a service that sits there and watches and waits and does something when that event happens. Same thing with wireless networks and so forth. And there's a kind of a consensus that you could do a lot more being PID 1 than just start up Apache and Samba and start the network and so forth. So there's the arguments for why it's time to replace System V Init with something better. Now, I don't have a slide on this, but I did discover as I was doing some research on this for the last couple of weeks that there are people out there that think System D is not a good idea. Linus Torvalds has had some things to say about System D that he doesn't like. I don't know if he's been very specific that he doesn't like System D, that he doesn't like the personalities that are involved in the development.
It's probably more if he has comments about the people involved.
Yeah, I mean, there's some of that, but I think that he has conceded that there are many aspects of System D that he agrees are needed in today's computing world. So there is a website out there called Boycott System D, and you can go out and read that. They've got all the arguments for why System D is a bad idea. The ones that are most that I can relate to the most is the fact that System D is written in C, so everything, a lot of the functionality is compiled into executables that you can't really open up in a text editor and look at like you would with an init script. So some of that stuff is hidden from view from your average system administrator, and so that's kind of a caveat. But at the same time, because this stuff is written in C, it's blazingly fast compared to Bash scripts. Any questions?
Just another complaint that I've seen is that by default, if you just have System D, it doesn't write to a var log messages file. It writes to its own journal CTL.
It can. So he says that that System D writes to its own journal daemon instead of to syslog. That's the way that like Fedora comes out of the box. It does that, and we'll understand why that they chose to do that. at the in a few slides, but it doesn't have to. You can run syslog. You can have stuff running to var log messages just like you'd expect.
Init didn't either. It had to start syslog to write to
Right.
the regular syslog places.
Yeah,
And
that,
you can still run syslog, and it'll write out your journal entries.
do one thing and do it well, though.
That's the argument.
That is that a lot of people complain that Systemd is kind of like the Emacs of process managers, in that it kind of disobeys this Unix philosophy, this Unix law of do one thing and do it well. Instead, Systemd tries to do a lot of things and do them well, but there's some feature creep is I think the complaint that some people have.
Are they trying to make this like a supervisor in the system?
Yeah. I can see that Systemd is kind of becoming an operating system of its own, in a sense. As we explore some of the features it has, you can see that Systemd kind of wants to take over the whole system and do everything.
Master control program.
Yeah. Pretty soon you don't even need to sit at the computer, and the Systemd will take care of everything. So there are some other alternatives to init. Fedora and Red Hat Enterprise have been using Upstart for quite a while, before they kind of switched over to Systemd. Upstart is an event-driven init system. So it's basically a init with some functionality to respond to certain events, like I mentioned before, plugging in devices and so forth. So Upstart is a little bit more aware of things that are happening to the system and adapts accordingly. Ubuntu's been using Upstart for a while, but Ubuntu says I don't know what version they're going to be using Systemd, but it's planned. Google's Chrome OS still uses Upstart. And then Gentoo uses this thing called openRC, and I know absolutely nothing about it. So
My understanding, the thing that Gentoo uses is similar to SysV Init, or System V Init.
okay.
Is it maybe based on BSD or something? They're very BSD oriented with their port system.
Okay, so now let's get down to Systemd and talk about what some of its features. You can use your old System V Init scripts. Systemd won't complain. As I mentioned before, it does offer parallelization. I love saying that, parallelization. And they say aggressive parallelization. So they try very hard to parallelize. Socket and dbus activation. This is one of the last things we'll be talking about tonight. These two go hand in hand, the parallelization and the socket activation. The socket activation makes the parallelization possible. Systemd can track processes via C groups. Yes?
Sorry, I'm just curious. When you say compatible with init scripts, but then provides aggressive parallelization, is there like a hint? Is there like embedded information in the script that can tell it this is parallelizable or something to that effect? Or?
I think if you want the most parallelizationable ability, if you want to parallelize to the maximum amount, you won't use init scripts.
Okay.
You'll use the native Systemd configs. But if you're installing a service on a server and it's running Systemd and all you've been provided is an init script, Systemd can use it.
Got it.
Okay, so C groups. Who here knows about C groups? I know Ryan does. Okay, so C groups, control groups, these are a feature of modern Linux kernels that allow you to kind of compartmentalize processes. And you can, from a security standpoint, they're nice because you can say, say I've got Boeing logging into this server and they're doing simulations or whatever. We can put all their stuff in one C group, and then when somebody else, some other,
Airbus.
pardon me?
Airbus.
Yeah, so Airbus logs in over on the other, they log into the same server. This doesn't really happen anymore, but back when I worked at Cray, it happened all the time. But yeah, Airbus would log into the same server. They'd run their simulations over here, but because the C groups makes it possible to keep them from doing PS and top and seeing what each other's doing, or so they can't see what processes the other person's running and so forth. That's one thing that C groups is good for. What's nice about C groups and the way that Systemd does it is that when you launch a service, sometimes you'll launch a server and it will launch children and then it will die and its children will continue running. But if all you have as the init process is the process ID of the parent, and now the parent is dead and these children are off doing their own thing, there's no way to kill the children. But if you launch everything within a C group, that makes it easy or easier to kind of isolate. Here's all the processes that are running within this C group, kill them. So you don't need to know the process IDs, you just need to know the C group for that service. So the C groups are very handy. Yes?
This might be out of scope, but what's the difference between C groups and something like LXC or Docker or any other?
Like what?
Like a Docker container or
Docker.
containers in general.
Docker actually uses C groups.
Oh, there you go.
To limit, say, CPU shares or how much a container, how much RAM a container can use.
Okay.
So when C groups first came out, this is just my limited knowledge from reading about them. They were originally called containers, kernel process containers. So I think it's a very primitive form of Docker. Docker's more of, this is a container for a whole stack of programs that are services that are going to be running on a server, whereas C groups at the kernel level is a way of kind of containing things.
In the actual case of Docker, it's just a wrapper around a bunch of kernel things, all the Linux containers, C groups, and all that stuff.
Okay.
Although it now supports.
You two, talk afterwards. Figure it out. So Systemd has native support for managing mount points. This is one of those things that init didn't do. Init handed this off to some scripts to kind of handle mounting, or an auto mount daemon that would automatically mount things for you. And then finally they have this, if you go to the Systemd website, they have one paragraph that kind of describes what Systemd does, and this is the last thing. It offers elaborate transactional dependency-based service control logic. So I'm just going to leave that, leave it at that, and we'll move on to the next slide. So currently adoption, Fedora uses it. As of Enterprise Linux 7, RHEL and CentOS are using it. openSUSE uses it since 13.4. Debian 8 will use it if and when it ever comes out. Ubuntu.
Freeze a couple weeks.
Ubuntu is going to be using it. Arch has been using it since 2012. And that's what I know. Does anybody else know of any, well-known distributions that are doing Systemd?
It's just about everything.
These are the big ones. Yeah, there seems to be widespread adoption.
It's getting used a lot in embedded Linux distributions.
Oh, okay. Cool. Levi does stuff with embedded Linux, so he knows. There's one semi-big distribution that's not up here, and that's Slackware. Slackware is still using the old, they might be using Upstart, but I think they're still using System V Init. So here's some.
I saw that Linux from scratch gives you two paths now. One
Oh.
is Systemd and one is not Systemd.
Cool. So here's some new concepts that you need to learn, and I think those of you who have been exposed to Systemd have already seen these and kind of scratched your head and say, I don't know what these are. How do these translate to what I'm familiar with? So let's talk about those. First thing is a unit, and as you get to know Systemd, you learn that units are the basic building block for everything in Systemd. So everything in Systemd is a unit. Services are a type of unit that you would commonly associate with a service that you would launch in the init process. So Apache is a service unit. Samba is a service unit, and so forth. Targets are analogous to run levels, but they are also a unit. Mounts are units that talk about something getting mounted on the system. There are others, but these are the main, kind of the core that most people will be exposed to.
There's network interfaces too.
Yeah, devices are units. And we talked a little bit earlier about this syslog stuff, the fact that System D kind of comes with its own component called journal D.
So, like, from a programming perspective, is unit like an interface, and all these other things implement something that?
What it comes down to is everything within System D, every unit within System D has a configuration file. So we call those unit configurations. So there's configuration files for the services, there's configuration files for the targets, there's configuration files for the mounts and the devices and the sockets and so forth. So, but System D says each one of these things that we can configure is a unit. So that just kind of helps dispel the confusion. You know, when you're looking at it and you're like, what the heck is a unit? Is this a unit or is this a unit? No, they're both units because they have configuration files associated with them. So yeah, the component, there are some components that System D now ships with, and one of those is Journal D, which is kind of its integrated logging system. And as I mentioned before, you don't have to have that enabled. You can use syslog or rsyslog or syslog-ng or whatever logging facility you want to use. Another one is login-d. This is kind of the System D component for handling user logins. And login-d has graphical widgets to handle the KDE and GNOME login features. These are things that you may or may not want to use. Fedora out of the box uses them all. And it's another example, as I said before, that System D is trying to kind of like get its tentacles into everything. And that may or may not be a good thing. Okay, so units, as I mentioned before, these are just configurations. Anything that can be configured within System D is a unit. Format of these configuration files is the desktop config format, kind of like a Windows INI. So you have sections that have square brackets around their name, and then something equals this, something equals this, something equals this, and, you know, for each section. And if you want to see more, you can look at the System D unit man page. So I've already kind of described units, so let's move on to services. Services are unit configurations to manage processes. So a service is often interchangeable with a daemon or a server. And these are things like Apache, Samba, NFS, Bind, SSH, D, that sort of stuff. Targets are used for grouping other unit configurations with some dependencies as well. So you can think of this as a run level. So that's one thing that System D gives you that kind of expands on the traditional init system. You don't have very strictly defined run levels. This is 3, this is 5. Now you can have an arbitrary number of different run levels. And you can say, okay, well, I want this run level, I'll call it foo, and I want foo to run everything. I want foo to do everything that target bar does. So you can have dependencies and a hierarchy of what services are handled by each target. To make things simple for the average administrator, they have targets that equate to your run level 3 and run level 5. On a Fedora box, the multi-user target is basically run level 3. And they patched programs like run level. When you type run level, it tells you what run level you're running. So they patched that so that if you're in the multi-user target, you type run level, it'll say 3. And same thing with graphical.
You can make up your own then, I'm guessing.
Yes.
That's the point. I used to use it before, so.
And I haven't really explored that territory yet, but I imagine like if you wanted your system under certain circumstances to do certain things when it reboots, you could do that by defining that target as something that also reboots the system, but also does all these other things as well. So that's what targets are. Mounts are unit configurations that manage mount points. What's interesting is the systemd developers realized that the fstab file was kind of authoritative. It needed to be authoritative. They could have very easily said, we're going to manage everything within systemd, and we'll just write out an fstab so that you can see what we're doing. But instead, what they do is they treat the fstab file as authoritative, and they read it into their own internal mounting format or whatever. But it pretty much everything that's in fstab is regarded by systemd as the law of what gets mounted and when it gets mounted and so forth. So you don't need to worry about, oh, I've got to learn a whole new system for dictating.
Like mount-A still works?
Yeah.
Okay.
Yeah. So they use a thing called a system generator to convert the fstab entries into mount units at boot time. So when you're booting, systemd comes up and it does this little system generator. I think it's just a fancy, it parses the fstab file and from that determines what needs to be mounted and when.
Question, is this in preparation for a reorganization of the fundamental file structure in Linux? We're talking about that.
I haven't heard that. Has anybody else?
Been a little bit of simplification, I think, of
Why have
Yeah,
user bin if you
Yeah.
have bin?
I would say probably
Or
it's
as
the system
been-
you guys pushing some of that along. So
Yeah, I haven't been privy to that, to any of that kind of talk. One thing that I just remembered that I should have mentioned earlier is the fact that the systemd guys, I guess, were inspired by LaunchD, which is Mac OS's kind of init system. So a lot of the stuff that that systemd does was kind of borrowed, at least in theory, from what Mac OS does. Yeah, Ryan?
Promise. So is systemd actively watching for file system changes on the fstab? Like, so if I make a change to fstab and I pull, save the file, is it watching the file for file changes to regenerate that stuff? I mean, how do
I
you-
don't know the answer to that.
That's fine. Just curious.
I don't
I-
think so. I mean, you're dealing with
I
an
don't
init
believe so.
system,
Right.
so
I just didn't know how far the tendrils went.
Right,
Is
right.
it like
Yeah,
I need
it's a
to
good
change
it's
it,
a good
like,
question.
He goes, oh,
I
I saw
can-
you made that
yeah,
save,
if
so
you-
I'll go ahead
if
and
you change
regenerate all
it
my
to
stuff.
your mount-A, that's going to work.
Well, I mean,
Beyond that, I mean, you're dealing with an init system, so it's going to do its stuff during the init,
well,
and then
So there
I
is
would give him right. I would do that.
there is a target that does that system the server generation,
Right.
and so if you did a reload on that service,
That would reparse.
then it would go through and reload the information from fstab and make those changes. So, but I don't think that it does it automatically, but I wouldn't put it past them.
Yeah, exactly.
All right, so when you're working with systemd, one thing that I discovered as I started learning more and more about systemd is that you can do almost everything with one command, systemctl. And Fedora and Red Hat Enterprise and CentOS all come with the old utilities that everybody's used to: service, check config. The init tab is still there. All these things that you're used to when you're doing system administration, they still work. They've just been modified to actually do systemctl calls instead of what they used to do. I almost wish that they hadn't done that, because I think it's holding people back from actually learning systemd. I know it did for me. I mean, I just kept doing service, restart, whatever. But systemctl, it's easy. You'll see. The other thing is, if you're going to be making any changes to the way that, or the order that things are started or whatever, you're going to want to dive into the unit configuration files. Yeah?
A good thing, like when you were saying that you didn't like how they kept the old commands and they just point back to the new commands, a good case of where they, or a good case for them for that is the enterprise environment, where you have all these old service scripts and you're still migrating to the new systems.
That's true. That's true. It's a good point. Because you'll have scripts on your system that do calls to check config or do calls to sbin service or whatever. Okay. So you want to start or stop a service under systemd? So this is traditionally done with service, or you just run the init script yourself, say, httpd start or restart or whatever. Here's my example. I never do things as root. I always do sudo. Sudo service httpd restart. Now you run systemctl start. That's the one thing that will throw you for a loop, is now the actual command comes before the name of the service instead of after it. But it's a little hurdle to get over, and then it just makes sense. So you do a systemctl start, httpd, or stop, or restart. So those concepts they translate pretty well from System V, upstart, over to systemd. If you want the status of a service, is the service running, or is it not running, or is it dead? Used to do service HTTP status. Now you just do a systemctl status HTTPD. Let me bring up a quick live demo. Make the font size big. Okay, so I don't even have an HTTPD. That doesn't help me.
So do yum install HTTPD.
What do I have that's running on here?
In my head. Package manager. I've got KDM in the process of replacing yum, so you never know.
Okay, let's see. Okay, there's an easy one. Let's get back over here and replace that with KDM. Okay, so the KDM is the KDE login manager. You get a lot more information from systemd than you do from your typical init script. Another one of the init scripts rely on a library for how they output their status information. So so you're not guaranteed a consistent format from an init script, because back in the old days they didn't have the colorful OK or fail or whatever inside square brackets. Everybody kind of wrote their own. That's one of the problems with the init system with the bash scripts, is you're really kind of dependent on everybody kind of conforming to a standard, and not everybody did. But so this gives you a lot of information. First of all, we have this line tells you that it's loaded. It tells you the service unit that that it was launched from. It tells you that it's enabled, so it's been flagged to start in this target every time. Right now it's active, it's running, and how long it's been running, and its PID, its main PID, because it might have children, and then we have some information about the C group, and then because I'm running journal D, I get the last few lines of the log messages that were generated by this service. So a little bit more information than your typical init script would give you. So let's go back over there. Okay, some more status. Here's something that init does not tell you. Let's find out if a service is active. Is it running? With systemctl, you can just say is active HTTPD. And this is nice, not so much from a user perspective, but if you want to write some scripts that you want to, basically find out, is this service actually running? Is it actively running? You can write this into your shell script. Here's another one. Find out if it's failed. Systemctl is -failed.
Does this have output, or is that just like an IC code?
Let's take a look at the output. So
Is that custom for the HTTP service, or is that across the board?
that's across the board.
So is there a list of all the across the board things that they've got that you can?
Yeah, if you do a man systemctl, it's all in there. And because in the one of the problems is with the init system, you have all these really poorly written init scripts that maybe only provide a start and a stop. They don't give you restart, they don't give you status, they don't give you a conditional restart, they don't give you a config checker, any of that kind of stuff that a really nice init script would. All they do is start and stop. Whereas what they've done in systemd is they handle all that transactional stuff, and the configuration scripts just describe what the service actually is. Not necessarily what you can do with it, but what it actually is. And we'll see that. We'll look at some...
Does it enforce you to have to implement each function?
The systemd does all that for you.
Oh. That's
So
You
let's
tell it what binary you want to use.
that's about it. All right.
so let's do an is active.
Neat.
Says active. So this is really good for scripting. Is it failed? Is a failed? It's active. So it looks like it's the same thing, And I guess let's look for some.
Yeah, what's the exit code on the is failed?
Unknown. So from a scripting perspective, that adds some value. Useful in scripting. Okay, so now what do we do about check config? We use check config to say, I want this on in this run level, that sort of thing. We would use check config to do that. Systemctl gives you an enable and a disable command for doing that. I don't know, there's probably some parameters that you can pass into systemctl to say, I want this enabled for this target, which is kind of like saying, with check config, you can say check config on for this level. So you'd say, I want this to run in run level 5, or I want this to run in run level 3. Systemctl probably has a way to associate a service with a target, but I didn't look into that. That's probably something for my notes, because this is the first time I've talked about this.
I think a lot of that's often stored in the actual unit files for the service itself. So that's kind of defined oftentimes by the developers of the service.
Mm-hmm. Okay, so default run level becomes default target. Traditionally, we would look at the init tab file and look down to see a line that says init default, and look for the number in the second column, and to find out what the default run level is supposed to be. or run level to see what the current run level is. You know, if you just boot it to a default run level. With System D, you just do a systemctl get-default. So if we go back over to the shell here. So it tells you what target unit the system will boot to. Okay, so if you want to change the default target, the old way, you edit the init tab, or you run some graphical system utility that lets you change it. I don't know. What is it that SUSE uses? Yast? You could probably change it in Yast. But in System D, you just do a systemctl, set default, and then the name of the target that you want to be default.
Probably still do it in Yast.
All right, so the next thing you want to do is get information out of System D, kind of like we did with the get default. Let's find out, what is it? Check config list will just show you every service that is on the system and whether or not it's enabled for the current run level, or it'll show you if it's enabled for all the run levels. So if you do a systemctl list-units, it will tell you everything about every unit that systemd knows about. Except, by default, it only tells you about the active units. So if you want all the units, then you add a -- all. Or I think you can actually do a list - all - units. And it's the same thing as saying list units -- all. You can list the units by type. So if you want to do the same thing as like a check config, you would say list units -t service. So let's do that. So if we do a so this is telling you all the services that are active and what their status is. Some of these things are not services that stay running. They just do something and then die. That's normal. So you'll see that they exited. KDM is it's loaded, it's active, it's running.
What about one that exits but not cleanly?
I'm sorry?
That's something that exits but doesn't exit cleanly.
It would say failed.
That's cool. All right.
So that's probably what most people are going to do. They're going to say, show me all the services. So let's look at devices, just for fun. This is another unit, another unit type. So you'll notice, there's devices managed within systemd for the sound card, for the wireless network adapter, for the different partitions on the SSD. In here, there's looks like serial devices. I didn't even know I had serial devices on this thing, but apparently systemd does. We've got a fuse down here for user space control of file systems, and a Bluetooth, and here's my hardwire Ethernet device and so forth. And what's interesting here is that these are plugged.
Could be just internal stuff.
What's that?
Could just be internal things in your computer, like say the keyboard.
That's probably one of the USB.
Yeah, they look like they're all bus enumerated devices.
Yeah.
So theoretically, you could plug something in and it would show up on the same bus.
You know, I don't see any USB devices on here. And I would think the
Maybe it
keyboard.
doesn't count the hubs and whatnot.
Yeah.
Where's the serial bus?
I want to know where my serial devices are. I want to use that someday. Okay,
Built in the chipset, not brought out on pins.
that's another presentation. All right, so yeah, you've got your type can be a lot of different things. Target. Yeah, let's look at target. That's an interesting one. Now let's get out of here first. So these are all the targets that are defined, that are active targets.
Nice thing is that the -T will work with the status command as well. So you can do systemctl space status, and then have it show you all the status of your system. Or at least I think it works with that. Instead of list units, do status.
I've never actually run status by itself. Now let's type it right. Okay, let's just type it. Oh, there's a lot of status there. So if we want to limit it to target, and maybe pipe it through less. So one thing to remember here is that unlike the System V Init, where your run level 5 has all these init scripts, well, they're actually symlinks to the initd scripts, but you have a concise set of these are the things that need to run for this run level, whereas it's systemd, everything inherits, includes. It's all very relational based in a sense that most of the targets may start this, do the basic target, and so the targets kind of become containers for services, and that's exactly what they are. Your graphical target would maybe start up everything that your multi-user does, but it also has units for other services as well, like KDM. So
It actually starts up the multi-user target as well.
say that again.
I think the graphical actually does start the multi-user target as well.
Yeah, so there's some inheritance going on there. All right, so let's look at the unit configuration files. Who here loves editing init scripts? It's fun.
First one time.
At Bluehost, we're building a whole new billing system based on an open source billing system called Freeside. And Freeside ships with an init script that sucks. And so, and it's an example of something that just does a start and a stop, doesn't give you status. And then, you have these services that run, there's no way to find out if they're, get a status on them and so forth. So a couple of months ago, I had the task of basically, and this one init script actually launched about 12, 14 different services, which made it even worse, because even if I did implement a status in this, big monolithic, huge init script that's in charge of 12 or 14 services, what kind of a status do I want to get out of that? So in the end, I talked to the upstream developers and convinced them that it was a good idea to actually split this out into individual init scripts for each of those services. And at the same time, I'll make them each 10 times better init scripts than what we have now. And so, yeah, I spent a good deal of time writing init scripts and kind of learning what's the best practice on init scripts. And because Freeside doesn't just run in a Red Hat environment, I had to make sure that that these init scripts played nice with Debian or any other platform that we were running on. So yeah, it's not straightforward or easy. It was fun as an exercise. I wouldn't want to do it all the time, but anyway, init scripts are hairy, and they're crazy, and they do a lot of things that after you've done a couple of them, you're thinking, why am I repeating myself? Systemd takes all that out of the way, because all you're doing in your unit configuration files is defining what systemd needs to know to do all that crap that you used to have to explicitly specify in your init scripts. So let's talk about where the configuration files are expected. Let's start at the bottom here. When you install a package on your system, it's going to install the service file or the unit configuration files in user lib systemd system, which is where the package provided configuration files go. The run systemd system is where the running configurations get copied to. And then if you want to make some changes, so let's say you take the httpd.service file and you want to make some changes to how it's launched, you don't want to edit the version that's in user lib. You make a copy of it up into etc systemd system, and you make your changes to that one, so that if you update, you don't overwrite. So if you update the Apache package, you're not overwriting the changes that you've made to your configuration. So the name of these is simply the name of the unit followed by the type. So we have like an httpd.service, graphical.target, temp.mount. That's, if you look in user lib systemd system on a systemd system, you'll see lots and lots of those types of files. So let's look at an example. Here's a service that runs OpenSSH server. I don't know if you've ever looked at the OpenSSH init script, but it's not 12 lines long. So let's walk through this quickly, and it won't take very long. First thing is, we have up at the top, we have a little section that allows us to describe this unit. We have a description. We have this after line that defines some dependencies. It makes sense to run SSHD after we have a network. So the network service needs to run before we do that. There's some other things. We need a syslog. We need audit D.
So that's effectively the dependencies.
Yeah. Okay, so the next thing we have is defining the service itself. First thing is we have an environment file. Systemd is going to basically load the environment before it launches the service. And you'll see down here where we actually have some environment variables that are, some of these are systemd environment variables. Like main PID doesn't come out of your sysconfig file. It comes out of systemd. But options does come out of, so if you want to override the options for SSHD, you would just edit your sysconfig SSHD file and create an options variable, and then it gets pulled in when, so here, this exec start pre directive says do this before you launch the service.
Can you have multiple exec start pre's?
I don't know. That's a good question.
Semicolon separated or something?
At least in the Arch config for this, what they're doing is instead of doing another, like the exec start pre, they put the SSHD gen keys script in another service file, and they require that.
Okay.
Yeah, and I was kind of puzzled by this. Why are they launching the SSHD keygen? Does this say that it needs to run every time that you?
It runs and generates the server side SSH keys.
Right. So the second time you run it, it'll say, "Oh, I've already got keys."
Exactly, and it'll bail out early.
Mm-hmm.
And from what I've seen, to further expound on your question, if you override by putting something in the etc systemd folder or whatever, it doesn't, like if you want to override like the exec start completely, you would put in your override file, you would put exec start equals nothing, leave it blank, and then put a secondary line of what you want it to override. Otherwise, it's kind of like combining everything together. So in your exec start pre, if you wanted to do others, you should be able to create an inherited unit file and just put more of those.
Like for example, in the unit section, you can have after syslog, after network, after audit.
So yeah, it looks like they're space delimiting things up there. You probably could space delimit other things. I don't know. Okay, so reload. This is what happens when you do a systemctl reload or restart. Reload is what you really want to do. You don't want to do a restart, which does stop. You're basically saying, hey, SSHD, reread your configuration files. So this is what systemd will run to do that. Kill mode. I don't remember all the different values for this, but in this case, we're actually killing the process ID. You can specify here that you want it to be a C group. So with the C group, you basically you're killing every process within the C group. There's a couple other kill modes as well. Here we're saying restart on failure. This is uncharted territory for System V Init to restart a service automatically if it fails. And then it's down here we're saying wait 42 seconds. That seems like a good amount of time to wait. Wait 42 seconds before restarting. And then down here we have, I don't really understand this part right here, but it looks like
I was saying which target is wants to execute it?
Yeah, when you do a systemctl space enable, that install section tells it which target to put it under.
well, what do you know?
That's what I was trying to explain earlier about how the unit files typically control what targets it's getting
Okay,
put
yeah,
under.
that makes sense.
Instead of saying enable in this target, it's kind of in their control versus yours, if you will.
Okay. So what you'll find when you do like an enable is actually the system is creating copies or symlinks to these unit files, and creating and doing that a lot of that happens in the run/systemd/system directory. So this is a fairly straightforward service unit. Levi?
It kind of reminds me of getting back to the days of using inetd to manage.
You know, there and I think the systemd guys have specifically said that inetd was kind of an inspiration for them, in the sense that and when we talk about the socket activation stuff, that's when it really makes sense. inetd was kind of the internet service super server. So inetd would listen on the ports that you enable, like say you had a talk server or a finger server or something on your server on your box. inetd would open those ports, and then as soon as somebody connected to the port, inetd would connect it to the service. So inetd was the one that was actually listening on all the ports, and it didn't actually start up the server until there was a connection that came through. So yeah, and when we get to this, to the socket activation stuff, it'll make it really sense. Okay, so we talked about the fact that systemd speeds up your boot process. Why? How? How does that happen? Well, let's look at the way your System V Init. Yes.
Are you gonna do a live demo with that? See how fast
Just
it
boot
boots?
up my system?
Yeah.
You're free to watch it boot. That's fine. It's a good idea, though. I have a feeling that this may become an Open West talk.
Yeah.
I think as people, I think there's going to be a lot of interest the next couple of years as people start using systems that are based on systemd. Okay, so yeah, if you've got feedback, email me and let me know. So System V Init starts up syslog as an example, and then it starts up dbus, and then it starts up Avahi, and then it starts up Bluetooth. Bluetooth needs syslog and dbus and Avahi to work, so those get started first. And after all that, let's start up SSHD. Okay, so it's everything. There's an order of operations here that has to happen. Well, with System D, we start up syslog, but we also start up all these others at the same time. Now, I just told you that Bluetooth cannot run without syslog or dbus or Avahi, but System D starts them all up at the same time in parallel. How? How is that possible? Socket activation is the secret sauce that makes this possible. So syslog, for example, creates a device called devlog. And so if you write to devlog, syslog takes that and does stuff with it. So obviously any program that depends on syslog is going to assume that there is a devlog device sitting there for it to write to. So systemd gives you the ability to say, before let's not worry about when this process starts or how long it's going to take to start, but we know that it's going to create a device that other processes are going to use. So just create the device and buffer its input until this other process spins up and does something with it. So in this case, syslog uses devlog, so you can configure systemd to create that socket ahead of time so that all the other things that are starting up in parallel will find that log device and start using it, even before syslog is ready to start using that data. So the SSHD service file that I showed you before is actually not used. I mean, it's shipped, but it's not used. And the reason why is because instead they have this configuration installed instead. So there's two files. There's an SSHD socket and there's an SSHD at.service that's enabled instead of SSHD. And so what's going on here, it's just like inetd, as Levi said. In here we say we want an internet socket on port 22. Systemd is going to listen on port 22 and just buffer up whatever gets. Ryan is head blown here. So let's walk through this real quick. Okay, first thing you have here is this conflicts with SSHD.service because we don't want this socket activation happening at the same time that we actually have SSHD starting up and doing its thing. So the next thing is we just define some characteristics of the socket. We want it to listen, TCP socket 22, and I don't remember what the accept does. I imagine it's accepting connections. And then down here we have the enabled secret sauce that says this is part of this target. So let's go look at the service that's associated with this. The service here, the unit description says, what's most important here is this is a per connection server. So this we're not firing up an SSHD that listens to all connections. This is an SSHD just for the one connection that hits systemd, and systemd says, oh, there's traffic on port 22. We better hand this off to SSHD. And the secret here is down here. If you launch SSHD with the -i, then it assumes it's being run from an inetd. And the standard input is a socket.
So it's going to fork
for every single connection that comes in?
So I just looked
Fun.
it up, and the accept line that you didn't know it did earlier, if it's true, or if it's on basically, it will go ahead and fork a new process for every connection. If it's false, it will pass the entire socket to the the process that's starting up.
So it's pre-fork, huh? That's terrible too.
Good stuff here.
So,
Okay, so that's socket activation.
Not liking it now.
It's pretty funky stuff, but that's how systemd boots up so much faster. And really, one thing that I read from the systemd developers was that the speed increases depend largely on like your disk, because if you've got a slow disk, then running stuff in parallel isn't going to give you a whole lot of gain in speed over like an over running things in parallel over running things in serial. So with an SSD like I've got, where you pretty much got random access to whatever's on the disk, it's pretty fast. Now you had a question back there?
I was just wondering, in this case, is it forking or is it actually creating another whole process per connection?
I think that we were talking about the depending on the parameters that you send to it. I think in this case it's creating a whole new process. So you would have SSHD process for every connection that comes in, because
Yes,
that's the way the inetd works.
I just quickly pulled up the man page for SSHD, and the -I option tells SSHD to run as if it's being spawned by inetd. So it is doing a new one each time, which SSHD, you have a forked SSHD process for every connection anyways.
Mm-hmm.
It's just a matter of who's listening on port 22, whether it's SSHD who then forks another one, or something else that forks SSHD.
Okay. There's a lot more that we could talk about with systemd, but I wanted to give you guys kind of a, here's the foundation on which you can build your systemd knowledge. So for more information, let's skip that page. For more information, there are some good man pages out there. Systemd service, systemd unit, systemd socket, and systemctl. Very good. There's a lot of different commands, systemctl commands that we didn't talk about that you can go in there and find out about. The systemd website is on freedesktop.org. There's some great YouTube videos. There's the six stages of systemd. That was a fun one to watch. They talk about the 6 stages of grief. The 6 stages of systemd is, the first is denial, anger, and then acceptance, jubilation. Anyway, there you go. I hope you guys are a little more, little less confused about systemd, and you're ready to go out and be systemders. Thanks.